All right, so we're going to look at factoring. All right, so earlier in the year I taught algebra. Okay, so within algebra, right, there's really different kinds of levels of it, right? We had monomials times another monomial. So for example, let's say I had a 3x squared times a negative 4x 4, right? The rule is that I multiply my coefficients and I add my exponents, right? So that was a monomial times a monomial. Then we moved into distributing, right? Where we had something out front. Let's say that I still have 3x squared. I'll make it negative this time. And inside, I may have a monomial. I would have a binomial, a trinomial, something different, like 4x squared minus 3x plus 5, right? Where I took the front and I multiplied it to the first one, and I got a negative 12x to the 4. And then I multiplied that 3x squared, negative 3x squared to the next one, and got a positive 9x3. And then I took the last one and I multiplied it to that one and got this, right? So distributing is where we have something in front and then we have something in the bracket. And by the act of multiplication, we get rid of the bracket, all right? So now we're going to go look at factoring. Factoring is the chapter that goes the opposite direction. We'll take a question like this and ask you what was the original question. Okay, we have to be able to go backwards and forward. All right. So this chapter, you're going to learn all the different ways there are ways to factor. I think 6 of them. 6 of them. And the thing that most people find is it's not the factoring methods themselves that is difficult. It's when to use them. So as I am teaching them, I'm going to make sure that you are aware of what you're looking for. Because really it comes down to how many terms are in the question. And that will tell you what to tackle. What am I looking for when I look at these questions? And you can eliminate them down to. All right? So we're going to look at what's called common factoring today. All right? So in the whole factoring realm, all right, in the whole factoring realm, there is what's called common factoring at the top. Let me move it down so you can see it. Common factoring. I'm going to shorten it down to CF, common factoring. All right. And knowing the names of what you're doing is also important when it comes to doing these questions. Knowing that, I need to common factor, and then maybe I'm going to do trinomial factoring or decomposition or grouping or that sort of thing. By naming it and saying, this is what I'm doing, then that helps reinforce what the steps are to it, all right? Common factoring is a method where you're always going to start with, this is your starting point, okay? Every question that you're going to look at in this entire chapter, you're always going to ask yourself, could I common factor it, okay? Because every single question out there is a possibility of common factoring, all right? Then after that, we kind of branch into 3 different kinds. And those all depend on how many terms there are. 2 terms, 3 terms, and 4 terms. No. And then it branches into how many terms there are. But common factoring, because I can distribute something into 1 term, I can distribute something into 2 terms in the brackets. I can distribute something into 3 terms. I can distribute something into 4 terms. That is kind of the overall one that can be done with absolutely any size of polynomial. So if you look at this first page right here, I've got things that are 2 terms big. I've got things that are 3 terms big. I've got things that are, I don't think I went anything bigger than 3, but you could go 4, that sort of thing. All right? So common factor, this is where we're going to start now writing. So when I write on this sheet, you can write it in yours. Okay? So And I want to make sure. Okay. So common factoring, CF, is the opposite of distributing. Okay. So you are looking for the greatest common factor. And I'm going to tell you what that is in a second. So the name of the factoring method is actually what you're looking for. Okay? So I'm looking for the greatest common factor. So let's break down those three words. All right? Greatest means the largest thing that I could possibly, that's common. The greatest thing is the largest, right? It is the largest thing. Common means that they all must have it. Right? If something's common between all of you, right, it's something that you all share. And a factor can be numbers, right? Or it can be variables. It's what makes up that question. All right? So it has to be the largest amount. It has to be common among all the terms, and it can be variables and numbers. All right? So let's go back to one of the distributing kinds of things. Let's say that I have 3x and then I have x minus 4. Okay? So in a distributing question, there's always what's common, or what the thing that you're going to give every other term goes out front. Then there's a bracket, and then can be a binomial, a trinomial, those sorts of things. And when I put this back in, I get a 3, and then I get an x squared, because 1 and 1 is 2. And then I get a negative 12 and an x. Okay? So now we're going from this step here back to this step. So if I give you this question, you'll notice that there is a common 3 between 3 and 12, right? Because that's what I put in. And there happens to be an x and an x in there. So when we look at this first question, all right, I'm looking for the largest thing that's common that could be numbers and variables. So I start with my numbers first. I look at 4 and I look at 12. This is where you're going to know your multiplication table is a big key to this thing. It depends on how fast you can do these things. The better you're at your multiplication table, the faster you'll be able to do this chapter. All right? So what is common between, the largest thing that's common between 4 and 12? And 1 is never an option. Well, 1 could be an option if there's nothing that's common. Like 1, if let's say that I had a 5 and a 12, right? 1 could be an option. Is there anything that is common between 4 and 12? No, it has to be within 2 and 4, right? Each have 2s and they each have 4s. Which is the largest of the two? 4. So I'm going to put that 4 out front. That's the largest thing that's common between both of them. Okay, and then I'm now going to look at my variable. I have an m in one of the terms, but I don't have an m in the other term. Could I remove an m from both of them? No. No, because the 12 doesn't have any m's, so how can I remove an m from a 12? Okay? I can't. So the only thing that's common between those two terms is the 4. Now I'm going to put the bracket. And now inside the bracket is what is left over. Well, I took the 4 out. I'm left with a m. Now ask yourself, does 4 times n give me 4m? Yeah. And then I have a plus. I didn't change any signs. And then 12 divided by 4 gives me 3. So that when I multiply those back together, it better be a 12. So there's no adding here. It's all multiplication or division. You want to look at it. All right? So there's the question. There's the answer. This is common factoring. Do you notice that I had 2 terms in the question? How many terms are in my bracket? 2. All right? Let's look at number 2. Again, that's it. That's common factoring. It gets a little harder, but, you know, that is essentially what common factoring is. It's figuring out what was that number that would have been distributed to all of them. Now I'm taking it back. All right?
Doesn't make sense.
Okay, well, that's why I have 10 examples. We've only done 1. Okay? You're probably not going to understand it after just 1.
Well, guys don't understand.
Okay, let's do another one. You'll see the pattern. So, 6 and 15.
3.
Right? 3 is common between them. That's going to go up front. Put what's out front, what's common. All right? This one has no A's and this one has an A. I can't remove an A out of either of them. So the A's are going to stay there. So I'm going to put a bracket and I'm going to write what's left over. I had 6, but I removed 3. So 3 times 2 would have given me that 6.
I think I got it.
You can divide, or you can think of what do I need, what's going to be left over. Minus
5.
15 divided by 3 gives me a 5 left over. What's left over? And I didn't remove the A, so the A stays. So far, so good? All right, let's go to the next one. I'm going to throw in something a little different.
What?
Now, there is one rule, okay, in common factoring. Because of the fact I said the common factoring was the first method that could work for every other question. Then after that, it kind of factors you could factor the question again according to another method. We always want, when we're doing this possibility of these other methods, we want our first term to always be positive. Our leading term should be positive, and if you look up on the board, I mostly have all leading terms that are positive. You may have ones that are negative, but we'll have to take care of that. So when you see that your first term is negative, you are automatically have to remove the negative. So if I remove a negative from every term, what happens to all the signs of those other terms? They all flip, right?
Big brain.
Okay, so I'm going to remove that negative from here. Let's see, what else is there common between the 2 terms?
Okay.
A 6. All right. So that's it. Now I'm going to put that right there, bracket. I'm going to look at my first term. What did I remove from the bracket? What did I remove from this negative 6n? I took the negative. I took the 6. That leaves me with a n left over. Now I'm going to go to the last term. I removed a negative. I removed a 6. What's left over? You can't say 0 because we're dividing.
Negative 1.
A 1. And it's not negative. It's going to be positive. Because I removed the negative. Because a negative divided by a negative is positive. 6 divided by 6 is 1. And the reason why I have to put a 1 there is if I did this, don't do this. Let's say I thought, I removed it all. I don't need to put that. What happens if I distribute that back in? Did I eliminate a whole term? Yeah. So if you remove everything from that term, you have to still put a 1. Because if I wanted to go the opposite direction back, all right, if I wanted to distribute back in, I've eliminated an entire term.
Okay, so technically you could put a 1 in front of the n.
You could, yes. If you wanted to put a 1 here, you could.
Okay.
It doesn't really change the answer, and you're okay if you want to put it in there. Okay? But this one is a necessity. Like, it has to be there, right? Because otherwise it eliminates your thing. All right, let's go to the next one. And then it leaves me with a leading term in the answer that is the possibility that maybe later on I could factor it again. Okay?
2.
So we're going to look at this. Okay, again, 6 and 4.
2.
We have a 2. Now, this one has 1 C. This one has 2 C's. You want the greatest number. Well, in your idea of thinking, it's the lowest exponent that I could pull out, I guess. Because there's 1 in here, but there's 2 in there. I can't remove 2 from both of them, right? Can I remove 2 C's from this pile? No, I've only got 1. This one has 2. What's the most I can grab out of both?
One.
One. Okay? I can only remove one. Okay? So now, I have this term. I have 6. I removed a 2. I divided by a 2. What's left over?
3.
3. I had a C, but I took it out front. I have no more C's in there. I'm done with that term. Then I go to the next one. Do I change any signs? No. I had a 4. I divided. I took out 2. I got a 2 left over because these have to multiply to give me that. And I had a C squared. I had 2 of the C's, but I decided to take 1 out front. So I have how many left over?
1 C.
1 C left over. There's we see in the pattern. All right. I'm going to up the amount of terms I've got now. No, it's not.
What are we going to use this for? Mother?
Somebody always asks that. It's used for absolutely anything that deals with math in the next 3 years. So after that, I'm sure there's some profession that uses it. It does come up again. The process of it comes up in engineering, anything you do with calculus, which is pretty much anything to do with high-level engineering or trades or that sort of thing. It is a process that you will learn that is used in every other chapter. It's kind of like, you know, fractions. Fractions can be in other things, right? I didn't just teach you fractions and then you never saw a fraction again. It was in the algebra chapters. It was in the, solving equations chapter. This type of thing, the process which I tell you, show you, deals with other things. So for example, my 11s and 12s use these factoring methods to add, subtract, multiply, and divide fractions with that had factoring within the questions.
So what you're saying is we just need this to graduate grade 12.
Well, it is, and depending on what you're doing after high school, it may be something that you're going to use again. It may not be. Majority of people, they'll never use factoring again, but the process is there and it needs to be used in other chapters. It's not an isolated thing. It's used in absolutely pretty much everything. The blue cards that are up on the wall contain factoring. Even though I'm teaching how to do logarithms and exponential form, it contains factoring within the questions. So it's kind of like a basics, a staple that goes with everything. If this was baking, this would be like flour. You can't make a lot of recipes without flour.
So it's kind of important.
It's kind of important.
Kind of.
I spend a lot of time on it. I will drill thousands of them into you. All right, so now we have 3 terms. That means, later on once you're done.
Let's go.
Okay? So I have a 4, a 2, and a 6. Okay? I need to remove a 2. That's what's common between 4, 2, and 6. And then I have 2 x's here, I have 1 x here, and I have 3 x's. I only have 1 x among all 3 terms that I can remove. That's it. Now inside my bracket, what's left over has to contain 3 terms. Because my original had 3 terms, my answer will have 3 terms. I had a 4x squared, I removed a 2x. That leaves me with a 2x left over. These two, when you multiply them back together, better give you a 4x squared. I had a 2x, I removed a 2x. What's left?
1.
Plus 1. Make sure that goes in there. You can't eliminate that spot. I had a negative 6, but I removed a positive 2, leaving me a negative 3. I divided it out. It's dividing. I had 3 x's. I took out 1. That leaves me with 2 left over. Okay?
There you go.
Number 6. Again, this one just happens to be backwards, right? It's actually an ascending order according to algebra, right? Descending order is squared, then a number, or an x, then a number. So you'll start seeing those kind of patterns. They are another kind of method of factoring too. All right, I have a 5, a 10, and a 5. Well, I guess 5. Can I take an x out?
No.
Well, I got 2 here. I only have 1 there. But this guy doesn't have any, so I cannot take
That
it.
guy no house.
No. So, again, I have a 5. I divide by 5. I get a 1. I had a negative 10x. I get a negative 2x. So far, so good? And I have a negative I removed the 5, so I just have an x squared. There we go. Okay, let's up the amount of variables and number size.
I did that one.
Good. So I got to see where you're being able to know what your factors are, like of your multiplication table. It helps. 18, 12, and 6. What's the largest thing? 6. Like there is a common 2, there is a common 3, right? But don't choose those because you're going to leave things left over and that's going to be wrong. You'll have to go as far as 6. What else do I need to take out?
An X.
The negative.
Oh.
Leading term is negative, right? Have to take out the negative. The largest number is 6. If I took out a 2, that would be wrong. If I took out a 3, that would be wrong. It has to be the greatest. And how many x's can I take out? 1. So I took out the negative. 18 divided by 6 gives me a 3. And I had 3 x's. I'm 2 left over. So far, so good?
Yes.
When I remove a negative, the signs all change to be the opposite, right? 12 divided by 6 gives me a 2. And I have an x. Positive divided by a negative is a negative. And I removed all of that. So I've got a 1. Okay?
I tried this next one, so I have to know that was right.
Well, you do the variables separate. Okay? So you look at your numbers first. Do I need to remove a negative? No. 12, 20, and 16. What's the common? 4. Then I look at only my x's. I have 3. I have 1. I have 2. What's the most? 1.
Oh, yeah.
Then I look at my y's. I have 1. I have 2. I have 2. 1. So you do each thing separately. Because think about when you distribute it in. You would have done the numbers. Then you would have done the x's. Then you would have done the y's. Then you would have done the numbers, the x's, then the y's when you distribute, right? What am I left with, Chloe?
A 3 and an X and a 2.
X squared. Good. And I removed all the y's.
Yes.
Nicole, what's the middle term?
Minus 5y.
5y. Good. Because I removed the x, I took out another y. Okay? Timothy, last term? So I have a negative. I didn't remove the negative, right? I had 16, but I divided by 4. What's left? 4. I have an x squared, but I removed an x. What's left? And I have a square y, right. And xy is left over. Does that make sense? Okay. Good. Not too bad?
Let's go.
Yep. It's a process. You learn and then you just got to repeat it. It's a very repetitive chapter. The first thing you learn is also in the second thing you learn. First and second are also in the third thing you learn. It's very repetitive. All right. Michael, do I need to remove any? What am I going to do with this thing? Okay. And what's common between 20, 30, and 25? Perfect. Bethany, how many C's can I remove?
2.
Good. Lexi, how many D's can I remove?
1.
Good. There it is. Hudson, what's left over in the first term?
It would be 30 C.
No, I'm in the first term.
First, oh, okay.
What am I left with that?
20.
No, I took out a 5. I took out a negative and a 5.
I am tired. It's
I
a
know,
4.
but
It's a 4.
Good. But what else?
C2.
Good.
There we go.
Perfect.
I am
Emmy, second term.
You would have positive 6, C1, D1.
Good. And you can put the ones on the D's and the C's if you want. You don't have to. All right, I'm done with that term. Emma, third term. Negative and a negative give me a positive, right? Oh, what do you got? All right, she took a D. Yep. Good.
Nice stroke.
So she went 25 divided by 5 to get a positive 5. She had 2 C's, removed them both, so she has no more C's left. She had 3 D's, but only removed 1, so she put a D squared there. Good.
The next one's
What's wrong with the next one, Nicole?
nothing like
There's no issue.
Nothing matches.
There's
Right.
no operators.
One.
So then they're just
One.
They're just in. That's
The
even.
bracket.
So really, 1 is the only thing, right? I could take out 1, but it leaves me with that. Well, I don't want to have to do that every time, right?
Yeah.
That makes no difference. So we don't write it like that, all right? If it doesn't factor at all, right, we call it what's called
A prid.
prime. Because think back to like numbers like 7. Break down 7 for me. 1 and 7.
Wow.
Right? What's 13? 1 and 13. We call them primes for a reason, right? They're the only numbers that is 1 and itself. Here's 1 and itself. So we call it prime. Later on, some of these questions might factor a different method, but they won't with common factoring. And then we won't use prime anymore. But in this case, there happens to be some that will not factor. That 1 and itself is the only thing. There's nothing common between 6, 5, and 8. This one has an x squared. That one has a y squared. This one has a z squared. There is nothing that's the same. And therefore, I write prime. All right.
The end.
There is
We have to do these.
lovely 45
We have
questions.
to do them.
Simon says, factor each of the following by removing the greatest common factor. Some of them are prime. There is never enough questions. There are 45 of them here, and then I have another 30 up on the board. So you will be factoring till the end of time.
no.